Welcome to the webinar entitled Wisconsin HIV Surveillance Annual Review, Data Concepts. This module should be viewed prior to viewing sections 1 through 4 of the Surveillance Annual Review, New Diagnoses, Prevalent Cases, and Deaths webinar. This webinar is being narrated by Ashley Buys, an epidemiologist within the Wisconsin HIV program. First, we will review the definitions of some commonly used terms through the annual surveillance report and webinar. HIV prevalence is the number of people living with HIV at a given time, usually as of the end of the year. HIV diagnosis refers to the time when HIV was first detected, whereas HIV incidence refers to when the infection was first acquired. Wisconsin does not receive federal funding to conduct incidence testing. Therefore, data are not available to determine when an infection was acquired, only when it was diagnosed. Therefore, the term HIV incidence is not used in Wisconsin HIV surveillance reports. Next, we will review adjusted or imputed risk. Each year, about 20% of people newly diagnosed with HIV are reported without a risk exposure. Therefore, data are often adjusted using a process known as imputation, so that those individuals can still be included in risk-based analyses. With imputation, the known risks of individuals with similar characteristics are applied to those with unknown risk. It is important to know that imputed risk exposures are estimates, not actual case counts.
Let's look at an example. Suppose there were 11 people, ages 45 to 64, diagnosed with HIV, and 7 of them were known to have injection drug exposure. 3 of them were known to have heterosexual exposure, and 1 had unknown risk exposure. The 10 known risks will be applied to the 1 person with unknown risk. In this case, 70% of those known risk were injected drugs and 30% heterosexual. So the person with unknown risk will be assigned 70% injection drug use and 30% heterosexual. Imputed risk exposures are subject to change as more information becomes available. This method conforms to CDC's method of addressing cases with unknown risk.
Next, we will review the use of rates. Rates are often used when comparing the impact of HIV across 2 or more groups. When the population sizes of the groups being compared are different, comparing numbers alone may give the wrong impression of disease impact. Graph 1 on the top right shows that 84 people in Group A and 95 people in Group B were diagnosed with HIV. We might interpret this chart as showing that B is more impacted by HIV than A. However, the B population is much larger than the A population. Therefore, we would expect more cases of HIV among Group A. In Graph 2, rates are used. This chart shows what the impact of HIV would be if the A and B populations were the same size. If the size of the A and B populations were both 100,000 people, 67 people from Group A would be impacted by HIV, compared to just 6 people in Group B. So HIV has a larger impact on the A population compared to the B population. It is important to note that these numbers do not reflect actual case counts, but rather an estimated case count if the populations were of identical size. Next, we will review rate ratios. Rate ratio is a method for quantifying the difference in the impact of HIV across populations. After rates have been calculated for each population, a reference group is selected, which may be the group with the lowest stable rate, the largest population, or other criteria. The rate for each population is then divided by the rate for the reference population, which gives the rate ratio. For example, using the diagnosis rates displayed in the graph and D as the reference population, we would say that the HIV diagnosis rate in A is 11-fold higher than in D. The 11-fold difference, or rate ratio, was obtained by dividing the rate for A, which was 66, by the rate for D, 6. Finally, we will review statistical significance. Statements about statistical significance are sometimes made when looking at a change over time or when comparing groups. Tests of statistical significance allow us to determine whether the observed change over time or difference between groups is most likely due to random fluctuation or whether it is likely to be a real difference. In the figure, the apparent increase in rates from 2012 to 2013 is not statistically significant. Therefore, this difference likely reflects normal fluctuations in HIV diagnoses that occur on a year-to-year basis, rather than a true increase. These are example rates and do not reflect actual rates in Wisconsin or elsewhere. Throughout the 2017 HIV/AIDS Surveillance Annual Review webinar, statements are made about trends only if the trends are statistically significant. Non-significant trends are described as stable or fluctuating. This concludes the Data Concepts webinar.